This video is one of three about the Python data model. We should probably begin by saying what that means. Well, if you consider what a programming language does, because the data model is going to help us understand how a programming language is organized. If you consider other languages and you consider how a language can be designed, the designer of a language needs to make a series of decisions about how data is represented, about how the language will allow you to store and retrieve data, how its functions work, how its operators work, but mostly about the data. We have data like numeric data. Sometimes it's integer data or float data. We might have string data. We might have binary data. There's a lot of just different kinds of data that a programming language is expected to manage and allow us to manipulate, as well as the semantics and the functions and the various tools that a language will provide to allow us to operate the computer in other ways, like sending messages over a network or operating devices or doing other kinds of things. So those choices are what make a language a language. I think I've said before that most languages do more or less the same thing. They allow us to operate the computer and they allow us to manage data. So the data model really outlines some of the choices that were made by Guido van Rossum and all of his successors in designing the Python language. So we're going to describe how Python is organized, and in so doing, we're going to show you a whole series of features that the language provides that allows us to kind of get under the hood of Python and manipulate things sort of behind the scenes. It's sort of like showing you the inner workings of an engine and saying, yeah, you can use the key to turn the engine on, but you can also reach under here and connect these wires, or there's some internal way to do things. That's sort of the way we should think of the Python data model and what we're going to be looking at. So it begins with the idea of objects and attributes, and really object attributes. In Python, you may have heard the phrase, everything is an object. That was one of the major decisions that Guido made in organizing Python. There are other languages that have values called primitives. These are non-object data values. In other languages, such as, let's say, Java, there are values like plain integers that are known as primitives in the sense that they're not objects. And Python has made the decision to make absolutely everything in the language an object. And that extends not just to int, float, string, list, tuple, dict, and set, but and none, which is null, and Boolean, which is true, false. There are other object types that might seem very unusual if you come from another language. For example, functions, class definitions, method definitions. These are entities in other languages that aren't necessarily objects. Now, it's a little abstract to say everything's an object until we start to get under the hood and look at the data model and realize that it's possible, since everything is an object, including functions, it's possible to look inside those objects and examine their context, something we call introspection. And introspection is something we're going to begin to do right now, but we'll look at in depth with some of the advanced features in an upcoming video. Let's begin by talking about attributes. Attributes are really where it all starts, and in some ways where it all ends. And we can begin, I think, by starting a terminal session and going into Python. Now, if you haven't done this many times in the past, The way you're going to do it is you're going to, we've said this before, but we'll say it again. If you're on the Mac or Linux, you're going to look for the terminal program. And if you're on Windows, you're going to look for the command prompt. I'm sorry, you're not. You're going to look for the Anaconda prompt. Now, if you don't have Anaconda, you'll need to make sure that your terminal session can see Python. That's the primary need for the Anaconda prompt. It's so that you don't have to set up your environment so that Python is available to your terminal window. That's neither here nor there, or that's too much detail. We'll start by opening one of these programs. And once you're able to do that, you should be able to, in the Mac or Linux, type Python 3. And if you're on Windows, type Python. So I'm going to take my advice here on the Mac and choose Python 3. On Windows, you'll use Python. When you do that, you see this special 3-arrow prompt. This is what we call the Python interactive prompt. It's going to allow us to execute Python code and do calculations with variables. As if we are, which we actually are, working on an interactive program. We can refer to that variable later if we wish, or any variable that we create during this session. But the terminal or the Python interactive prompt is actually a lot more useful in the sense when we want to do certain types of looks at our objects, when we want to inspect our objects, when we want to try little experiments and examine our objects. And one of the primary reasons I ever use the interactive prompt is to take a look at the attributes of an object. Now, the standard way to do this is with the Dur function. This is going to show us all the attributes that are available to an object. Here you can see I said dir A. A is a string hello. I could have just said dir string, or even dir stir would have worked. And what I'm seeing here are all the attributes that are available to this particular object. Now, we've looked at this in the past, and I think I've identified for you that everything you see that has no underscores in front and the back of it in the string class are methods that we can use with the string. The truth is, most of these others are methods as well, but we won't get to these until a later video. For now, we're just going to think about this list of strings as showing us the names of all the attributes that are available to the string object or to this particular object. Let's talk about, let's say, a method that we know, lower. We can, of course, use, we have A here, A is hello. We can, of course, use the method and it'll work, or let's say a.upper and it'll work. But what we'd like to do is take a look at what we see when we don't try to call it. Now, you know that calling a method means using the parentheses. If we don't call it, we actually see what this attribute points to. This attribute points to a method. And in fact, we'll see that everything in a string points to a method. So when we use dir, we're able to see a whole list of the attributes that are available to the object, and you should be able to view each one of these if you wish, or any one of them. So the first thing to understand is that everything in Python is an object. And one of the things that we know is always true of every object is that the object will have attributes. Now, what is an attribute? For a string, it's a method, but we see other attributes that aren't methods. We can see attributes that actually point to other things. For instance, let's look at an object that you might not think of an object, the module. You know that when you import a module, you're making other Python code available to your program, as it is when we say import CSV and then CSV reader, or import JSON and say json.load, or when we say sys.arg for sys.path.join, the various methods and other kinds of functions that we've used. Obviously, when we're saying something like sys.path, we're accessing an attribute. But it's a little bit different with a module because a module's attributes are actually its global variable names. Now that's something we haven't talked about in quite a while, but if you have a module that has global variables, the global variables in the module are the attributes of the module object. Before we do, actually, let me just say what the type of sys is. Do you see how it says it's a module? Okay, this is an object too. We can do whatever we like with this object that we could have done with other objects, like pass them to functions or store them in lists or store them in dictionaries. You can do a lot of things with these objects. But let's just focus on the idea of an object having attributes. What are the attributes of the sys object, the sys module object? Well, there's quite a few of them. In fact, there are many that I've never seen before, never really looked at, and that you may not as well. But we do see ones that we can recognize, like syspath, or there's some other lesser known ones that are kind of interesting to look at, or sysargv. Remember sysargv? Sysargv is always there. There are others like sys.copyright, which shows us the copyright notice for the Python installation, or sys.version, which shows us the version. Now, I'd have a question for you right now. When I show these objects in the Python interpreter here, you should hopefully be able to see what type sys.copyright and sys.version are. They're both the same type. Can you tell? Well, you see that there are quotes around them, so that would make them strings, and sure enough, they are. If I say type of sys.copyright, I see a string. On the other end, if I say type of sys. Let's say stir.upper, I see method. Okay, well, method descriptor method. We'll just call it method descriptor, but it's still a method. Here's the thing. Every attribute of an object points to another object. Every attribute of an object points to another object. In the case of stir.upper and attributes that we're very familiar with, it's pointing to a method object, right? A method that you can call and it will do the work you're expecting. Other attributes, however, could point to entirely different types of objects. For instance, sys.argv points to a list, or sys.version points to a string, or sys.copyright points to a string. So the main idea is this. Everything's an object. Every object has attributes. And every object points to another object. Sorry, every attribute points to another object. Now it's important to understand this because this undergirds everything that Python does. Everything that Python does and everything that Python is based around this idea. Everything that you run into in Python, aside from things like statements, for instance, the if statement is not an object. The def statement, the class statement, these are not objects. And operators like plus or times, these are not objects. These are actually just syntax that we can make use of. But everything else besides statements, and we can say operators, which really aren't anything at all. We'll explain that in the magic methods video. Everything's an object, and that means that every object has a type. Let's say that as well. And every object also has attributes. Now, what an attribute means for an object varies between, depending on the object type. For example, for standard objects, attributes are, well, we're actually going to have to explore this to really say. So let's talk about some of the tools that we can use to take a look at these attributes and explore. Because one of the things, one of the primary things I would want you to come away with is the ability, or at least the facility and understanding, that when you're working with any type of object, and there'll be many objects that you've never seen before, objects that belong to different modules that you've installed and used. And we're going to be looking at, we have been and will be looking at many more custom modules that are designed to do all kinds of custom things. For instance, we'll be looking at pandas later on, but we've also looked at Beautiful Soup module. We've looked at the requests module. We've looked at, things like the CSV and JSON module, SQLite and other SQL modules. Every one of these modules produces objects, or themselves are an object. The module, of course, is an object. And we should know that at any time we can explore that object and see what it's about. For instance, let's talk about again, if we look at the string class and we see the attributes that are part of that class, if the class is a method, if the attribute points to a method or a function, we can find out about that. For instance, to do that, we'll use the help function. So if I say, let's say stir.split, if I say help of stir.split, and I'm holding here because when I hit enter, it's going to clear the screen, I'll see help for that object. The method split, which as we can see, returns a list of words in a string using separator as the delimiter string. A very, very small, short, very terse, and hopefully helpful documentation on it. And this, of course, also extends to functions that we might want to explore. If we do the dir of, let's say, JSON, let's import JSON and do the dir of JSON. Here we see a series of attributes of the JSON module. Now, don't forget what I said about attributes of a module. They are the global variables in that module. Usually that means that the attributes of a module will be functions in that module. For instance, we use json.load, but json.load is not a method. It sort of seems like it is, but it isn't. It's a function of the JSON module, and we can learn about that by using help. So if you're not sure how to use any function or attribute of any kind, if it's a function or a method, you can look for help on it. And we'll explore exactly where that help is located and how you can define help for your functions and your methods as well. Now, Dur is a very good approach to seeing, the attributes that are part of a module. I'd like to explore now how where attributes come from and what they mean. I'll tell you right now, just to start, that for built-in objects, the attributes usually point to methods. Usually, not always, but usually. And that's also going to be true of a lot of the objects that we create. We can also say that for modules, attributes point to global variables within the module. So, like I said, load in JSON is not a method, it's a function. It sort of looks like a method because we're saying JSON.load parentheses. But no, it's a function of the module. It's a global variable in the module that's defined as a function. Now, I'd like to explore this further using built-in classes. So I'm going to jump to what is, as of this writing, the 7.6 in-class exercise. The number may have changed, or who knows, even the exercise may have changed at the time that you're watching this video. But as of right now, which is in February of 2021, this is 7.6 in the in-class methods, or in-class exercises. So take a look at this class. As you can see, it's a pretty basic class. It has two variables that belong to the class. One of them is an integer and another is a function. Now, what we're doing right now is exploring how attributes come to be and what they represent in different kinds of objects. as I mentioned, for a built-in object, it's usually a method. In modules, it's a global variable, whatever that global variable might be. And with sys copyright, it was a string. With JSON.load, it was a function of the JSON module. When we look at a custom class of our own, first thing I'd like to express is how the object itself, the class itself is an object. For instance, I could maybe print the type of do. Now, what am I looking at when I'm looking at the type of do? What is do? Well, do is a class, obviously. But remember, we said that everything in Python is an object. So this gets a little bit confusing. It's important to understand that even a class definition is an object. Now, it says class type, but type and class are very, very closely aligned, and they're more or less synonymous. So we can think of it as saying class, which would be pretty funny to see. But here's the other thing that we can know about a class object is that it also has a set of attributes associated with it. So we can look at that list here. Now, I want us to notice, if you look to the very end of this list of attributes, because we've got a lot of magic attributes that we haven't yet elucidated, although we plan to do this in time. If you look closely, at the very end of the list, you see two names there, cval and do this. Now, what are these variables? These are not like module variables. These are class variables. This is a class variable. This is also a class variable. And a class variable, as we saw when we looked at classes for the first time, a class variable is a variable that's defined in the class. That is, any function, which is a method defined in the class, is a class variable. Let's say we can say this is an int, and we can say that this is a method, right? Because we know that functions defined inside a class are known as a method. But they're also available in the class through its attribute list. So we're able to see the attributes for the class using Dur. We're seeing a lot of others as well, and so a question might come up. What are all those other attributes doing there that are clearly not part of the class definition? Why do we have all these extras? We're going to see. Now, there is another way that we can look at the attributes of an object. Not all objects, but many objects. And that is using a special attribute of the object. So I'm going to print that as well. This is called the Dict attribute of an object, and we can see it up here. When we look at the Dict attribute, it shows us this dictionary. And I think just to make it a little clearer, I'm going to ask for just the keys of the Dict attribute. And there they are. These are the Dict keys. Now we're seeing cval and do this. We're seeing Dict. We're seeing weakref, doc, and module. Doc we are going to look into. Module and weakref. Actually, if we look at module, I think we're going to see what that is. Module is just a special introspection attribute that tells us what module this object was defined in. This is defined in main, which of course means the one we're in, not in some other module. Okay, not so important. What I'm trying to get you to look at is the different ways in which we can look at attributes. And one thing we're seeing is that dir as a function shows us a lot more attributes than dict, the attribute of the class that shows us also shows us attributes of the class. So one big question that we're going to have on our minds right now is why we see so many more with Dur than we do with Dict, and what's the difference there. For now, I'd just like us to understand that the function is here, function Dur, and also the Dict attribute, which tells us about attributes of the class as well, and that they're different. We're going to see the difference in just a moment. So remember, variables that are defined in the class become attributes of the class. We think of them in both ways. the class can both define its attributes as its variables in the class, or they could even be defined as attributes of the class directly. For instance, I could say do.myNewAdder equals hey, and when I do a dir on it, I'm still going to see it. And there's my new adder. So it's kind of interesting to see how this is panning out. It's going to be a little bit challenging to keep all of it in mind, but stick with me. We're going to keep exploring this, and hopefully with a little repetition, it'll start to become more clear. I'm going to go on to the next exercise, and I'm now going to discuss this in terms of not just a class, but also of an instance of the class. Now here you see a slightly enhanced do class, which has not just an integer attribute or integer class variable and this do this method that we can call, but it also has a init. Now last time we looked at classes, we looked at what a init does. Init is an initialization method. Init gets called automatically when we create a new instance of the class. And what that init is doing is setting an attribute in the object. So if I print, for instance, I print obj.oadder, I'm going to see 500 because it's an attribute that was set in the instance. In fact, we could go a little further and just set another object instance. Let's call this new. I've never uppercased an attribute. I guess I'm not going to start now. New adder equals hey. And as we saw when we looked at classes for the first time, you can retrieve any attribute you wish. When you look at how attributes can be set in the object and then how they can be retrieved from the object, well, I hope we can understand that attributes kind of act like a dictionary in the sense that when we say something like obj.newAdder equals hey, we're saying let's let the key newAdder be associated with the value string hey. We're setting a key value pair in the object using the attributes. But of course, as we saw, it goes a little further than that, because besides setting our own attributes and being able to retrieve our own attributes, we're also able to call methods from the class. Now, this is something that we did when we explored classes for the first time. But we're seeing that the instance of the class has access to the class attributes. It starts to get really, really complicated, but hopefully with a little repetition, you can get it straight in your head. Look at line, I'll call it line 23 and line 24. Or, I'm sorry, let's do it this way. Now look at lines 24 and line 25. When we print new adder, we're going to see hey. And when we call object do this, we're going to see done because it called it. Now when I ask you about the difference between the access of the attribute in line 24 and the access of the attribute here, in fact, let's make it even better. Let's just make these almost the same. Now, if I want to access an attribute of the class, or if I want to access an attribute that's in the object, you can see that they're both accessible from the object, from the instance. obj.cval and obj.newAdder, do they look any different to you? And yet newAdder and cval are located in entirely different places. One was set in the instance, and I could do the same thing with OAdder. And this would get me 500. Two of these attributes were set in the instance. Can you see which ones were set in the instance? One is new adder. That was set in the instance. And the other, OAdder, was also set in the instance. And we talked about how self is the object. So saying obj.newAdder equals and saying self.oAdder equals are really doing the same thing. They're setting attributes in the instance. But then we also have an attribute that was set in the class. This is how attributes work for objects that we create and objects that you'll run into when you look at other people's modules, other people's code. You'll see other objects out there that you can access the attributes, and the attributes can be those of the instance or of the class. Now, if you need to, maybe take a pause and stare at this a bit, because I'll try to label it here. This is a class attribute or variable. Init is a class attribute or variable. Do this is a class attribute or variable. And what we're doing here on line 17 is setting an attribute in the instance. And then below, we're accessing these attributes and even setting a new attribute in the instance. So if this seems at all confusing, it may work for you to pause this video and stare at this for a little bit until it makes at least a little bit of sense. I recognize that without a lot more to sort of hang your hat on, it may be difficult, really, to understand all of this. We've got a series of rules, which maybe I should continue to elucidate here. But go ahead and pause if you feel like you'd like to. So let's take a look now at the difference between Dur and Dict. Now that we understand what's going on here, I'd like to show you the difference, what the real difference is between Dur and Dict. For instance, I will say the Dur of obj, and then, after maybe a little visual barrier, I will now do obj.dict, and I'll use keys just so we can see the keys. Now, I'm going to show you this output, and one is going to be of Dur. Here, I'll get rid of these for right now. One is going to be of Dur and one is going to be of Dict. Let's see what it looks like when we run these and see the results. So here's the list of attributes for obj in Dur. You can see it's from Dur because of the list here. It's a list. And then below that we see the dicts, the keys for obj.dict. Maybe actually I don't even need to use keys. It's a little clearer to read. Yeah. Okay. Now, let's do this. Take a look at the list that came back from Dur, and that is all the attributes for obj. And then compare it, look at those last few attributes, and then take a look at the attribute keys, the keys that are in the Dict attribute for obj. I think you can see that each of the attributes in the object, that is OAdder and newAdder, are also represented in the Dur. So Dur is showing us oadder and newadder, but it's also, oadder and newadder, but it's also showing us attributes that are in the class, cval and do this. So what is the difference between Dur and Dict? Dur shows all attributes that are available to an object. And Dict, it's not a method, it's an attribute that points to a dictionary, is a dictionary of all attributes that belong to an object. And actually, there is another function that I'm just getting used to now called vars. And vars, I believe, will show us something similar to what Dict does. Let's try that here. Rather than using Dict, I'm going to use print vars of obj. I like to show it as a Dict attribute because it kind of emphasizes that this is part of this object. Yeah, it's really doing the same thing. Vars is showing us the attributes that belong to this object. So then what does it mean to have the same attributes in both Dur and Dict? And clearly to see that the attributes that are in Dict are also in Dur. Well, again, Dur shows all attributes that are available to an object. Now we learned that the rule of an instance is that it has access not only to its own attributes, but also to attributes of the class. That's how we can do things like call obj.doThis or look at obj.cval. These class attributes or class variables are available to the instance. Now, I don't know if you remembered when I was saying that, when we looked at a class that has its own attributes, here's the do class, and we see D and do this. Is this the one we looked at? Thought it was. No, 7.6. When we look at a class that has cval and do this, and we can also set attributes in it, we looked at the Dur of do, and we saw a lot more than cval and do this, didn't we? So this shows all names of attributes available to do. This implies, of course, that those attributes are available to do, but where do they come from? Well, we'll look at that when we get back to inheritance. So let's look at the Dict of do. Because again, remember, Dict was supposed to show us, or did we just do this? I think we did. Just the attributes that are available or that are belong to the class. So we'll look at that with new eyes. We see cval and do this. We see Dict, we see module, we see doc. Weakref is very, very special, and I'm still a little unclear on what it does. Doc we'll have to explore in a little bit. Module we saw shows us the module that the class is part of. That is, the current script. And I guess we can go ahead and do the vars of do and see the same thing. We're going to see a dictionary, and that dictionary is going to have key value pairs. And I guess if we look at the keys of it, we'll see the same thing. Okay. Still probably a little bit strange, but we want to keep all of this in mind as we do further exploration. Every object has attributes. The attributes can be discerned by using Dur and Dict. But there is a distinction, and we can say that vars obj, returns the Dict dictionary. So vars is just a convenient function for getting that as well. We know that Dur will show us all attributes that are available to an object, and we saw that that made a difference, of course, for any instance of a class, because an instance of a class has access to the class attributes. But we also saw that Dict will show us the attributes that just belong to that object. We also mentioned that attributes mean different things to different objects. Beep, beep. For built-in objects, they usually point to methods. For modules, they point to global variables within the module. For classes, attributes point to, well, are set as variables in the class definition, or as attributes of the class object. And for an instance of a class, attributes are set as attributes in the instance, but instance also has access to class attributes, the attributes of its class. Now, it's pretty involved, and it would be interesting for you, I think, if you were to look this over several times and play with it yourself. Play both with built-in objects, with modules, and with classes that you define and instances of that class, so that you can see the different ways that attributes are used. Again, these are the attributes that we're going to run into as we do our further exploration. There'll be attributes either of an instance, of a class, of a module, or possibly of a built-in, and they mean different things. They're always going to point to an object, but they'll just be accessed in different ways and available in different ways according to the rules that we just described. And Dur and Dict are the ways that we can use our introspection powers to look at the object and see what attributes were defined in the object and also what attributes are available to the object.